All right, let's do this again. So I have over here some data on football teams, and I did this on a very specific year for the NFL. There's 32 teams in the NFL. 32 teams. I did this in a very specific year. I brought these data from a specific year that the Patriots won all their games and the Dolphins just won one of their games. I put this in here because we get that variation between 16 and 1. Normally the variation in the NFL is not that big. It might be this year because the Browns might not win anything, but we have a lot of variation. And I'm going to try to predict how many wins each team had this year by how many points they're scored. I'm going to see how well points you score translates into you winning games. Okay? Everybody with me? So we click on data. We click on data analysis. Up pops our friend regression right there. We click OK. Which one of these is Y? Well, wins is Y, right? Wins is what I'm trying to predict. That's why I'm going to try to predict how many games we win. Okay? If you're saying to yourself, why would we ever do this? Well, there are people who do this, right? There are sports bettors who actually try to do this, who try to take characteristics of teams and try to figure out who's going to win and who's going to lose. If you go to ESPN.com, they have a kind of a attached website which does a lot of statistical analysis on teams to try to predict who's going to win and how much they're going to win. Okay? So points per game is X, wins is Y. I have labels. Labels, that's a label, that's a label. I have labels. And we're going to put this in a new worksheet plot. And again, we're going to click on residuals and residual plots so it will graph the errors for us. Are we ready? Are we ready? Yes, we are. It's going to click OK. Now we have to make some of these columns wider because, again, whoever programmed this stuff at Microsoft really doesn't know what they're doing. And again, I hate this part, so I just get rid of that part. And here we have a regression equation. Okay? So we have multiple r 0.87. The highest that could be is 1. We have an r square of 0.76. That's this squared, right? If I take 0.872891762 and I square it, I get 0.761940028. That's that squared. Remember, there's this adjusted r square, and they should be close, and those two are pretty close, so we're okay there. The 0.76 says that 76% of the variation in wins, 76% of the difference in wins between the teams can be explained by knowing how many points they scored. And obviously there's lots of other things that would explain the other part, how good their defense is. Did they turn the ball over? Okay, there's other things. Then we get a standard error of 1.6. That says if I try to estimate how many games a team wins based on how many points they score, on average I'm going to be off by 1.64. Well, you're in big trouble then, right? Because you might want to use this equation to go down and bet on the sports book at the beginning of the year of how many games a team is going to win. But if you're off by 1.64, you're not going to make any money. You're going to lose your shirt and other body parts. Okay? Notice that we have 32 observations. In total, we have 31 degrees of freedom. But really, we have 30 degrees of freedom. We have 2 minus 2 variables. 32 minus 2 variables is 30. That's the most important thing. Okay? So come down here. We have A and we have B. The intercept is A. Points per game is B. So we have A of minus 4.6 and a B of 0.58. So let's go back up here. We don't need that. So we have a B of minus 4 point something. Do you remember what that was? 4.59. That's just where the line starts. It's impossible to win a negative number of games. And then B is 5.8. What does 0.58 mean? Well, let's think this through, shall we? That means wins equals minus 4.59 plus 0.58 times points scored, right? And that's average points scored over the course of the season. So what's that mean? If I average one more point scored over the course of the season, I win about a half a game. So roughly, because I'm playing 16 games, one more point. Roughly, every 2 more touchdowns I score over the season, on average, I'll win a half a game. And you're like, well, you can't win a half a game. Okay. So on average, about every time if I increase my scoring by about 4 touchdowns over the course of a season, on average, I'll win one more game. Okay? All right. So we'll be back to that in a minute. All right. So, again, the standard errors, we're going to find out whether these things are valid. Are these guys valid? Well, to find out if they're valid, again, this is the test we run. We take B divided by the standard error. And in this case, we got a T of, take 0.58, divide by 0. We get a T of 9.7. So our T in this regression is 9.7. Our critical value, 30 degrees of freedom, 1.645. We reject that there's no relationship, and that tells us there is a relationship. Okay? Or we can look at the p-value. The p-value, strangely enough, is 7.33 e to the minus 11. So the p-value looks like that. That's a really little number. Okay? That's the probability. That number right there is the probability that there's no relationship between how many points you score and how many games you win. There's definitely right? That means there's a 99.999999993% chance that there's a relationship between how many points you score and how many games you win. Okay? That's pretty good. So let's go back over here. Tells us there's a good relationship. Tells us this. R-squared and the standard error still tell us we're not all that happy with this, right? If we really want to use this for some purpose, it's not good enough. It's a C, right? 76% is a C. We're not going to make money in the casino on a regression equation that's a C. We need to get that up to being an A. But the one thing that's better about this than last time is look at our little dots here. That's random. Those dots are scattered all over the place. Okay? So at least we have random residuals. The residuals are not with a pattern. R-square is good. The T statistic is good. Standard error is legal. And the errors are random. Okay? The errors are probably bigger than we'd like them to be, and the standard error is the measure of that, and it's certainly bigger than we'd like them to be, and R-square is smaller than we like it to be, but there's nothing about this regression that's technically invalid. Okay? So what it says now is we can come back over here, and for example, we can say if we score 20 points a game, we score 20 points a game, how many games should we win? Now we can predict that. So we can come back over here, and again we go right here, and we say equals B17 plus B18 times 20. Okay? And it says if we score 20 points a game, we should win about 7 games over the course of the season. That's not very good. We want to score more than 20 points a game. Okay? But again, it's not as accurate, perhaps, an estimate as we'd like it to be. Right? We good? We happy? It's how we interpret a regression.